Hey guys, welcome to C++ Pointer Basics. I'm Code Mason. I'm going to be walking you through this very simple tutorial on, well, hopefully it's simple, but basically the basics of C++ pointers. So after I tried to make this into one large YouTube video, and after I kind of went through a lot of it, turns out that it's actually much longer than I want it to be, and I don't want to put y'all to sleep too much. So I think what I'm going to do is break this up into three parts, as we see, and this will be part one that you're looking at, where we'll look at some of the basic dynamic pointers, primitive pointers, object pointers, and then pointers to existing variables. You can read all that, so no need for me to repeat it. But again, this will be part one, and if there's enough interest and when I get around to it, I'll do part two and part three. So because I don't want to waste too much time, especially since I suspect you all know a lot of this, what you'll need to know is basically having a level one knowledge of C++, that is basically knowing the basic variable types, control structures like ifs, fors, everything you'd expect around what we'd call a CS1 or Computer Science 1 level knowledge of C++. Classes, I'd expect you to know about how to create classes, how to instantiate them with the constructors, and also knowledge of basic arrays. So if you do not know those things, please go back and maybe check out some videos or do some research on the low-level stuff. If there's enough interest, I can certainly do a tutorial on that at some point. But just don't want to waste time going through a lot of the low-level stuff. In that same vein, IDE, Integrated Development Environment, you're free to use your own. Every piece of code that we're doing here for this part will work in any IDE. I'm using NetBeans myself, but I've used Visual Studio as well as any of the other command line tools that you can use to edit and compile and run your C++ program. So definitely need to have that base level of knowledge before we get into this. So yeah, let's get started. All right, guys, so the first thing we're going to look at with a pointer is we're going to start off very simple. We're just simply going to make an integer pointer or an int pointer. So let's start out with what we know already. Let's kind of just declare a variable called I. And we've all seen this before. I'm just putting this in at first just so we kind of start off with a good baseline that we know of things that we know, in case we're not familiar with pointers at all yet. And all I've done here is I've declared an integer called I, and I've assigned it a value of -8. So they are, very simple code. I'm not trying to do anything fancy here, just kind of showing you to relate what we're getting ready to do to what you already know. Well, when you declare a variable, a pointer variable, you need to include, before the variable name, you need to include this asterisk or the star. And what this line tells the program is that, or tells the computer, is that we want to declare a variable called IP, and we want that variable type not to be an int, but we want it to be an int pointer. What is a pointer? A pointer is nothing more, and I want you to keep this in the back of your head as we go through these series of showing you all this pointer stuff. A pointer is nothing more than a memory location. It is a number. It is an address, if you want to think of it that way. It is a unique address in memory. So everything in memory has a unique address associated with it. And by including code like this, what we're saying is we want IP to refer to a memory address where an integer is located. And that is pretty much it. It's as simple as that. What makes it hard, I think, in C++ is when we actually try to use it, and some of the syntax that we use that kind of makes it confusing. But we're here to walk through some of that, so let's continue. So let's say that I wanted to assign a value of -8 to IP. Well, I do not do this. This is the wrong thing to do. What this will try to do is assign IP to the memory address of -8. This is, chances are, something that we don't want to do. What we want to do is we want to put at that memory address -8. Now I'm going to show you something, and hopefully it won't confuse it yet. I kind of got a little bit ahead of myself, but let's just continue on. So the correct way to code this is like this. You want to use what's called the dereference operator. Yes, it is an asterisk, just like it was when we declared the variable. But when we use it in this case, we call it a dereference operator, because when we put it right before as a prefix to the variable name, what we're saying is that we want to reference wherever IP is pointing to, whatever address IP is pointing to, and we wish to place the value of -8 at that point. So it's very important, it's crucial that you understand the difference between dereferencing a pointer and assigning the value without the asterisk, without the dereference operator. And we had to dereference it once again because we're trying to place this value wherever IP is pointing. Now, so the next question might be, well, where is IP pointing to? So that was kind of where I got a little bit ahead of myself here. This code is syntactically correct, but it will be a runtime error. And the reason why is because IP is not pointing to anything yet. We never initialized IP to point to any location. So let's get IP to point to a dynamic memory location by including this code first. This new int, or the new operator, is more what we should talk about, is the dynamic memory allocation operator. What this does is this asks the operating system for memory that's large enough to hold an integer. And what the operating system will do, the operating system will go and it will find memory that's big enough to hold the number of bytes needed for an integer. So we need to do this, and this new int line here, this will return the memory address and assign it to IP. So for instance, perhaps the operating system decided to assign the memory address of 100. So IP would actually equal 100. Now, it probably won't do 100. I'm just trying to make a point here, is that IP now points to a location where values can be placed. So let's kind of output what's going on here, and hopefully it'll clear it up a little bit. So the first thing we're going to do is output the address. You'll note that I'm not dereferencing IP because I basically want to see the memory address of where IP is pointing to. We assigned it to the expression, the return from the expression new int, so we can look at what that value is. Then I'm going to output the value behind it. And if you remember what we said, if you want to refer to the value that's being pointed to, that is the value that IP is pointing, the value behind that address, we need to dereference it. And let me just highlight this and just make sure we understand that this expression that I just highlighted is an int expression because IP is a pointer to an int, so if we dereference it, we should be looking at an int. So let's just run this and hopefully we'll have an idea of what's going on. Now what do we get with the address? We got this hexadecimal number. So address, and we got that 0x. The only thing the 0x means is that whatever follows it is a hexadecimal. So we could have done it as an integer. That is, we could have outputted it as an integer if we wanted to see what that hex equals. But when we deal with memory addresses, we deal with hexadecimal numbers. It's just a base 16 number. Hopefully you all know about that. And what did we get for value? We got that -8 that we placed there. So we dereferenced it, and you see that in the line right before that, we actually had assigned what it's pointing to the -8. Now normally what we do with pointers, we don't have to worry about it here because this is a very small program, but normally when we deal with pointers, we're going to use that dynamically allocated, this is where we dynamically allocated that value. We're going to remove that from, that is, we're going to deallocate that memory. So the first thing we're going to do is we might use IP in some way, maybe through 1,000 lines, maybe through just a couple. It doesn't matter. But when we're done with it, we want to get in the habit of deleting the address, the memory associated at that memory address. What does that do? What that does is that tells the operating system when we deallocate, let's put that as a comment. When we deallocate that memory, what's basically happening is that we're telling the operating system that we don't need that anymore, and that the operating system can use it for other purposes. And we like this dynamic model because we're only using what we need, and this is allowing us to have very large programs where we can properly manage memory and deallocate memory as we need to. So this has just been a very basic kind of introduction to pointer using a very, very basic integer pointer. We're going to get a little bit more complex as we move on, but just wanted to start easy. In the next section, we're going to look at a couple of slides that will hopefully drive the point home of what we talked about here. All right, guys, what we want to look at now is what we just saw in code. We want to look at this a little bit more graphically. Pictures are worth 1,000 words, so hopefully this will help clear up some of the problems that we have with pointers and understanding what goes on behind the scenes. So we have two tables here. We basically have a table of all, not all, but just a very abbreviated version of all the memory addresses, and we can see that they're all unique kind of thing. And then over here on the right side, we have basically a table of how the operating system works. We all know that the operating system is the operating system that is responsible for memory and other pieces of hardware inside of the computer. And one of the jobs of the operating system is to monitor that memory. And so we're kind of starting off with everything being available just for demonstration purposes, because the operating system needs to keep a track of what's available, which memory addresses and what blocks of memory are available, and which ones are occupied by which programs. So we're just going to kind of look at this and see what happens as we walk through our code here, which we'll start right now. So we did a declaration of an integer pointer. We've already seen that. That would simply be the operating system decided to put that in memory address 3008. But that's the address of not where the IP variable is pointing to, but the value of the memory. And we'll see how that works in a moment. But we just want to note that the operating system knows where the IP variable lives, basically at this location. And we don't have a value for IP yet because we never assigned it. So we've seen this, maybe you've seen this, where you try it, where when you first declare a variable, it has what's called an undefined initial value. You can initialize it if you want to, and there are ways to do that, but for this code, we're not doing that. Okay, moving on. Now, if we assign that IP equal to the new int as we did, a couple things happen. First off, we can visualize this IP pointer pointing to memory location 3040. Where did we get that? That was the memory location that the operating system decided to give us when we said, give me memory large enough to hold an int. The operating system can give you whichever of its available memory spaces, but we're just going to assume that it decided to give you this 3040. So IP, again, has the value of this 3040, and we can visualize it as IP is pointing to that memory location. So now what are we going to do? We're going to dereference that IP, that is, dereference where IP is pointing to, and put the value -8 there. And you can see that -8 is now in that location. As we mentioned before, the asterisk dereferences the memory that is pointing to. Now what we would do theoretically is do something with the IP variable, whatever we need to do with it. Output it, use it as an argument to a function, whatever we need to do. But the point is, when we're done, we're going to delete that memory. So once again, this value here at the 3040 becomes undefined, but something else is going to happen over here. That is, that memory address will now become, that status at the 3040 becomes available once again. We've given that memory back to the operating system. I think we mentioned the terminology before, but this is what we call deallocating, one of the words for it, deallocating memory that was associated with the IP value of 3040. Now that value is still sitting there, it doesn't do anything with the IP, but right now you wouldn't want to try to write that -8 to it. You don't want to try to assign it to -8 because it's no longer available for us to use. And if we tried to do something like that, we'd probably get a runtime error. And it's a lot of times it's a good practice to assign your variables once you delete them, to assign it to the special null value. Null value is nothing more than 0, really. You can see that here. And it's more of a flag. I don't want you to think of it as IP actually pointing to memory location 0. I want you to more think of it as a flag that means it isn't pointing to anything, because if we tried to do something with the IP, that is, if we tried to dereference it and do something, we would get a runtime error. So we use that null value. It has to be capital NULL, I believe, unless that's changed in some of the later versions. That is a flag for us that we can use with in a lot of cases to, again, just to indicate that that pointer isn't pointing to anything more so than it's pointing to memory location 100. So that was just a graphical representation of what we just saw in our code, and hopefully that cleared things up a little bit. Okay, guys, wanted to move a little bit up in complexity, what I think will be the last part of this first part of this series on pointers, and look at making a pointer to a class. Before we do that, I just want to make clear that we used an int pointer for our examples before, but we could have made it a, dp equals new. We could have made it a double pointer or a pointer to anything else, any of the other primitive types. So we have double, bool, short, long, whichever. We could have made a pointer to all of those types as well, and we could have dereference that and set that equal to, whatever value that we need to. So all this code works, and then when we're done with this, obviously we delete DP and everything would work fine. So we can do code like this. So you can do this with any of this type of thing with any of the primitive types as I mentioned. But we don't want to do pointers just to those types, to those basic types. We want to be able to do pointers to our objects. So I've created a car class here that has two constructors. We have the default constructor here that will simply assign a gray color with a top speed of 0 and a cost of 0. Where did I get that from? I have three attributes here: color, top speed, and the cost of the vehicle, just to demonstrate how all this stuff works. I also have another constructor, a 3R constructor, that allows me to assign each of those values. So nothing there. If you don't know about classes and objects in C++, you'll want to learn about that probably pretty quickly, because it's a very huge part of C++. But let's go ahead and make an instance of this car class. I'm just going to call it lemon with a color of yellow. What was the next thing? Top speed of, 120, maybe 5,000 bucks. Okay, so we've made an instance of this. Now, we haven't really dealt with pointers yet. I just want to kind of once again, establish a baseline of how we use this sort of thing. So I'm just going to do an output, and what I really want to concentrate on here is the way we access our members using that dot operator. So let me just finish this up first and then we'll talk about it. Lemon dot cost is what I want. Costs and an indel, I think will do that. I seem to be fat fingered today. Okay. So a very simple program, and we're going to run this just to see what we would get. And as we hopefully have anticipated, we're simply going to see my yellow, I don't know if you can see that, but it says my yellow car. That's what I meant to put. Cost that much money. So very simple type of processing there. And again, the thing to note is that I use the dot operator to access the members. I want you to keep that in mind because we're going to use this a little bit differently when we deal with a pointer. So let's just kind of save this code off down here in case I need it later, which I probably won't, but maybe I will. So now let's look at a car pointer. Well, we know that we need that asterisk once again to state that this variable that I'm getting ready to make, nice car, I don't know, I could have thought of something better than that. But what have we done here? We have declared not an instance of car. It's very important to understand that we have not made a new instance of car when we do this declaration. This only makes a pointer to a car. And as we know, a pointer will refer to a memory location that contains a car. So if we're doing this dynamically, as we did the last time, we would say something like nice car equals new car. And I'm going to use the 3R constructor. Sleek blue. Top speed, I don't know, let's call it 210, and we'll give it a cost of $30,000. Okay, and 99 cents, why not? Okay, so what this has done now, the new car, now this will instantiate, make a new instance of the car in memory. There's actually a car now that's sitting in memory, and we can change the color or whatever. But let's just go ahead and do this cout. Again, I'm going to copy what I have here, and we're going to see how this will change. So not lemon this time, but we're going to do new car, nice car. And we don't use the dot operator when we deal with an object through a pointer. We use, instead of the dot operator, we have to use this minus and greater than sign together, what we call the arrow operator. If we access attributes of an object through a pointer, we have to use the arrow operator. And we're going to see now that we're going to get synonymous code to what we saw before. And you see that that all works. We got a little rounding here that happened with the .99. That's just because this IDE, I haven't, it looks like the default rounding is to round that number. I can easily change it if I wanted to, but I'm not going to worry about that. Now let me show you some synonymous code. Because this has to do with the dereference operator that we used before. If you remember, when we dereference a pointer, we basically refer to where that pointer is pointing to. So if we're going to dereference it, we're not going to use the arrow operator. We're going to use the dot. Now I have to wrap this dereference into parentheses because of the order, the evaluation order, or the hierarchical order of the dot versus the dereference operator. I believe it's the dot that has a higher precedence, so we just have to put some parentheses around it. But that's no problem. But I just want to show you that these two pieces of code are synonymous. Which one would you do? Well, it kind of depends on the situation, I guess, but you can see that both those lines do output the same thing, and they do the exact same thing. Once again, when I am done with this nice car pointer, this nice car, I'm going to delete it from memory. Or I'm going to deallocate that location because I'm done and I want to give it back to the operating system to use for whatever purposes. Again, it doesn't matter for this short program, but if we were dealing with a very large type of video game or something where we're constantly allocating and deallocating things, we want to make sure that we don't use more than we need. Okay, guys, I had actually said that there was a previous scene that I just did where I said that was the last part of the series, and actually I think there's one more part I want to include. Sorry about that. Y'all thought y'all were out of here, and I'm keeping you around for a little bit longer. But anyway, I think a discussion of pointers isn't really complete unless we talk about the address of operator. And I do want to give you all kind of something somewhat complete-ish discussion of pointers before we leave here. Again, I do plan to do some more parts to this dealing with things like array of pointers and things like that. But I do want to at least talk about the address operator, and I think that's important. And in a lot of books, it's usually the first thing that they discuss. So anyway, enough talk. Here we go. All right. So I brought back our lemon car once again for that. We knew that that was an instance, and we now have our pointer, nice car, that point to null. Sometimes you want to be able to point a pointer to something that already exists. That is, I want to point nice car to the lemon instance and use that. So before we were doing something like nice car equals new car, and we were actually using, we're doing that, sorry. We were actually doing something like this where we dynamically created memory for a car, but you don't have to if you want your pointers to basically share something that already exists. So in other words, like I said, I want this pointer to point to the same address as lemon. And what you're in essence going to get is you're going to get two references to the same memory location, both through the lemon variable as well as the nice car variable. So I wouldn't go nice car equals new car. I want to point it to the lemon. I don't want to do this because we're not done yet. Because what this would do is this would try to point a pointer to an instance. And these are two different variable types. You're talking about a car pointer on the left side here is the receiver, and you're talking about the value as being a car reference. We want it to be the address of where that lemon is. How do I get the address? I include this yet another operator, the ampersand, what we call the address or the address of operator. When we prefix that to a variable, what we get is lemon's memory address. And once again, let's do a few things here. First off, I want to let's change yellow, the color yellow, to, I don't know, let's go with lime, something like that. That may capitalize for some reason. I don't know why. Okay. Notice that I changed the color through the nice car variable. Now, when I go to output, though, I'm going to actually output through, and we're not going to do a whole bunch. Let's just do the car color for now. We're going to output it through the lemon. So again, lemon's car started out as yellow, and we could have done a print before that, but I think we're getting the point here. But I'm changed because I'm now referring the nice car to the same address, and I'm changing it through the nice car. When I look at this color, it's going to be lime at this point. And this just proves, hopefully, that that even though I changed it through the nice car, because nice car and lemon refer to the same memory location, this is why this works. I can, if I wanted to, I could assign, several hundred pointers to the same memory location, and any change through to that variable at that point would be reflected through everything that is referencing that. We'll kind of see that again, I think, in the next part that I plan to deal with arrays of pointers, but definitely wanted to introduce that address operator. Now, another thing you'll note here is you do not, even though it's syntactically correct to do delete nice car, I do not want to do that. You only want to deallocate or delete memory that you have allocated with the new operator. Do not try to do this here, or you will get a runtime error. The memory location in nice car is referencing right now is the same one as lemon, and it is not a deletable or a reclaimable, at least not through the delete operator, memory. So that's it for the address operator.